My guest today is Alvin Wong.
Today, I want to sharing our findings about the volcanic eruptions and extreme weather events. And I studied the volcanic eruption since my master degree in Earth System Science in China's University of Hong Kong, and supervised by the Professor Wei Xin, a retired professor in University of Hong Kong. And he expressed it the role of volcanic eruption can have a great impact, uh, like the submarine eruptions, which is always underestimated by the people. And I like one sentence she said, uh, is if we put a little bit of warm water in the bathtub, the whole temperature of the bathtub can be changed. And that is a serious impact later. And just like the volcanic eruption, if eruptions occurred in maybe the uh, Atlantic Ocean, it can also affect the weather system in the Pacific Ocean, like Hong Kong, New Zealand, Australia, and not just the ridge. So the role of the volcanic eruption is always underestimated in the issue of climate change and extreme weather. So I joined the volcano study group of Hong Kong, which held by the Professor Wei Xin, and we keep doing research about the impact of volcanic eruption in the climate change issue and in the climatic variability. So today in this presentation, I will take some example to show that how the volcanic eruption affects the Earth system from atmosphere, and the oceanic circulation, and finally leading a series of extreme weather events. And this study was presented in the AOGS conference in Singapore in 2023, and it is also a contribution to the volcanic impact on climate and society. So this is the general flow about the presentation today. And I will, is here we can see if there is really part of the example of volcanic eruption and extreme weather events. And I will show that how the sub-area volcanic eruption affect the Hong Kong rainfall record in 1982 and 2008. And second, I will talk about the geothermal heat from the volcanic eruption, how it affects the ocean circulation and causing the ocean warm ball. And finally, it is a very famous and rare volcanic eruption in history, which is 2021 to 2022 Hunga eruption. And this eruption is very interesting because it not only released the volcanic aerosol to the atmosphere, but also release a large amount of geothermal heat to ocean and the water vapor to the atmosphere. And it can have a great impact to the Earth system. And the impact can be last for the several years. So here is these are the two news about the flooding in Australia and Hong Kong. Maybe some of you think that this kind of the flooding, the extreme weather event, is related to the climate change, and it can be attributed to the human activity because human activity always release a large amount of CO2, and it changed the climate. So that's why we always see different news about flooding, drought, other kinds of extreme weather event in the globe. But if I tell you these two of flooding events can be explained by the volcanic eruption, do you believe that? I can tell you that this is a very interesting topic, and I hope after listening this today's presentation, I can change your mind and increase your awareness of the role of volcanic eruption on the climate change issue. But first of all, we should know that the definition of the weather and climate. Weather is the state of atmosphere at a specific time and place. It describes short-term atmospheric condition in contrast to climate, which refer to a long-term average of weather pattern. We always, from hours to a week, 2 weeks, the weather pattern. So second, the climate is the long-term mean state of weather pattern in a region. Generally, average over 30 years. So one of we always know is for example the global temperature always the trend of the global temperature is increasing. So this is a climate example. And so after that, the climate change is a long-term change in the average weather patterns that have come to define Earth local, regional, and global climate. And finally, the extreme weather. The meaning of extreme weather is includes unexpected, unusual, serious, or unseasonal weather pattern. For example, flooding, heat wave, cold wave, heavy rainfall, and some typhoon storm events. These are the extreme weather. And these figures I made in my past research, and I hope after reading these figures, I hope everyone can generally know the impact of the volcanic eruption. And we can see there are 3 types of volcanic eruption. First is the subaerial volcanic eruption. Mostly, the subaerial volcanic eruption will release some volcanic materials like the aerosol, sulfur dioxide, water vapor to the atmosphere. And the aerosols from the volcanic eruption can reflect the solar radiation, and it can change the atmospheric temperature. And finally, it can change the whole atmosphere from lower level and upper level. And also the sulfur dioxide from the eruption can change the cloud formation and causing us and change the rainfall pattern. So I will talk about the Hong Kong extreme rainfall event in 1952 and 2008 later to explain how the subaerial eruption changed the Earth system and finally caused the extreme rainfall event. And the second type of the volcanic eruption is submarine eruption. And I have read both many research, and I think there are not too much research on the impact of submarine volcanic eruption because there are many difficulties to observe the submarine eruption and collect the data. And so there are not many research studies on the impact of submarine eruption on the Earth system. But based on our findings, we found that the submarine eruption can release geothermal heat and change the ocean temperature and favor the formation of ocean warm block. This ocean warm block can increase the latent heat flux, which can favor the cloud formation in the atmosphere, and finally can favor some cyclone formation and the rainfall pattern. And also the ocean warm block can change the pressure distribution over the ocean and can change the trade wind pattern. Also can affect the pattern of ancient. For example, during the 2013 to 2015, the Nishinoshima makes eruptions in Japan released a large amount of geothermal heat during three years and formed the North Pacific Ocean, and it favors the formation of the El Nino during the 2014 to 2016, and caused a series of extreme weather events in the United States and some other places, and also decreased the Arctic sea ice. And I have completed a study on this topic in my master's degree. And finally, the third type of the volcanic eruption is the mixed eruption, which means it includes the impacts of subaerial volcanic eruption and the submarine volcanic eruption, like the Hunga eruption in 2021 and 2022. And I also will explain these events in my presentation today. And first of all, in this slide, we can see that there are six dry and wet years in events in Hong Kong, which can be explained by the volcanic eruption from nearby in the Pacific Ocean, and from Indonesia, Mexico, Philippines, Chile, and Japan and Tonga. And in this volcanic eruption, released a large amount of volcanic aerosol to the stratosphere, and the volcanic aerosol transported by the wind and the monsoon wind from the volcanic eruption site to Hong Kong. And interestingly, the timing of rainfall records in Hong Kong over the period 1963 to 2022 matched with the volcanic ash movement and the e-folding time of 23 to 35 days for the conversion of sulfur dioxide to sulfate. And after the conversion to the sulfate can react with gases to form aerosol that block sunlight. And the volcanic aerosols can act as a condensation nuclei that favor cloud formation and obtain the rainfall amount. So finally, in Hong Kong, it records some records. It breaks some records record in 1982 and 2008. In some years, we can have a lower record, rainfall record. And today I will only talk about 1982 and 2008, how the El Chichon eruption and the Chichon eruption affect the Hong Kong rainfall pattern. And first of all, in 1982, the El Chichon eruptions occurred and with volcanic explosive index 5, which means it's, the level, the magnitude of the eruption is very huge, according to this index. And based on the satellite image, the ash cloud from the eruption, the height of the ash cloud is about 26 kilometers, and about 27 billion tons of volcanic eruption materials released from the El Chichon eruption. And some scientists used some satellite image to track the volcanic ash from the El Chichon eruption, and it finds that the sulfur dioxide from the El Chichon eruption only used 21 days circled the globe, and around April 16 in 1982, this volcanic cloud reached Hong Kong under the monsoon wind. On the 16th of April in 1982, the volcanic ash cloud from the El Chichon eruption reached Hong Kong, and on that day, the record of low relative humidity is observed in Hong Kong, based on the data from the Hong Kong Observatory. But after the volcanic aerosol reached Hong Kong, this stratospheric aerosol settled through the troposphere and provide condensation nuclear for cloud formation, and it changed the rainfall pattern in Hong Kong. After 3 days of the volcanic aerosol reached Hong Kong, on 19th of April, a few rainfall was recorded in Hong Kong, and later on, around 22 of April, the rainfall record became heavy and reaching about 70.9 millimeters. The timing of the humidity change and heavy rainfall in Hong Kong coincided with the movement of the volcanic cloud produced by the El Chichon eruption. And in 2008, Chichon eruption in Chile occurred, and it is another example to show that how the volcanic eruption can affect Hong Kong rainfall pattern. And the VEI, the volcanic explosive index of Chichon eruption, is about 4, and the ash cloud column height is around 30 kilometers. And in the modest satellite image, we can see that the eruption cloud form a continuous linear and sharp edge curve, and the volcanic ash moved the southeastward and reaching the Atlantic coast of Argentina. And finally, in the method data, we can see that the volcanic ash moved across the Atlantic Ocean and it also move to the distribute to the Indian Ocean. And finally, the volcanic ash reached Hong Kong and caused heavy rainfall in Hong Kong after 35 days of the volcanic eruption. And it also matched with the evolving time of sulfur dioxide, the conversion of sulfur dioxide to sulfate. So the volcanic ash from the Chichon eruption reached Hong Kong, and under the southwest monsoon condition, the north and northeast direct volcanic cloud with over 30 kilometer altitude was tracked by satellite and affect Hong Kong and provide condensation nucleus for rainfall. And in this figure, in this image, we can see that the whole Hong Kong record at least 200 millimeters of rainfall from so in a day on 7th of June in 2008. And also it broke the record of the highest 1 hour rainfall on that day with around 153.5 millimeter. And it is a good example to match the new definition from Hong Kong Observatory, the exceptional surf rainstorm, which means the rainfall intensity exceeds 140 millimeter in an hour. And also, in June of 2008, it is the wettest June and the sixth wettest year since 1884 in Hong Kong. So we can see that the Chichon eruption affects the Hong Kong rainfall pattern, and it breaks a lot of the rain weather precipitation record of Hong Kong. And finally, the extreme rainfall in Hong Kong caused over 2,400 landslides occurred in Lantau Island. And this picture, we can see that the seriousness of the extreme rainfall event in June and in 2008 in Hong Kong, caused by the Chichon eruption. Not just the Chichon eruption affect in Hong Kong, it also affects the weather in other places. For example, we can see there are some wet weather in June, during May, between May and June in South Africa and in Australia, and the record winter rainfall in Western Tasmania, following the arrival of the volcanic cloud from the Chichon eruption. And both the rainfall extreme event in Hong Kong in 1982 and 2008, it caused enormous loss to the Hong Kong community and the Hong Kong economy. And in this two tables, we can see that the volcanic eruption caused a series of rainfall events in Hong Kong, and it broke the rainfall pattern in these 2 years. And 1982 is the second year, the second wettest year in history, and the 2008 the sixth wettest year in history, which caused by the eruption in El Chichon and Chichon. And also we can see that the eruption caused the rainfall in April and May in 1982 was double the average. And it also the 9th and 8th, the 5th wettest April and May on record in 1982. And also, we can see the situation was the same in 2008. And we can see that the Chichon eruption break the Hong Kong rainfall record in June, and it caused the rainfall, the monthly rainfall amount in June almost nearly triple to the average. And the June of 2008 was the wettest June on the record. So, in this two examples, we can see that even the place far away from the eruption site, the eruption can also have a great impact on the weather pattern of the place, like the El Chichon and the Chichon eruption and the extreme rainfall events in Hong Kong.
Right near your cursor there, I'm wondering why in 1982, near the cursor, that June and July had quite low rainfalls, even though the rest of the months around that had high rainfalls. And then in 2008, June and July had enormous rainfall. I'm just wondering if there's something special about that season that made the rainfalls outliers during June and July.
Oh, I didn't have many data about this aspect, but maybe the high pressure system affect the rainfall pattern in Hong Kong in June and July. But we can see that the volcanic eruptions can last in the atmosphere in several months, and combined with the monsoon wet wind pattern and the so combined with the monsoon pattern in summer season, so that's why we can have a great rainfall amount record in Hong Kong from August to October. So basically, in Hong Kong, under the monsoon wind in summer, we receive the high rainfall amount. But in 1982, combined with the impact of the El Chichon eruption, the rainfall amount is increased in the history compared with the past. So basically about this.
All right, thank you. Thanks.
So, and maybe Professor Wisdom can have a better explanation of this question.
Thanks.
So we can see that the volcanic eruptions can have a great impact in the global weather pattern. The place far away the eruption site, not just affect the surrounding area of the nearby the volcanic eruption. And second, I will talk about the geothermal heat from the volcanic eruption. And this topic, I think not many study about this on the impact of the geothermal heat from volcanic eruption. And here, we can see that several volcanic eruptions from 2012 to 2022 this eruption released a large amount of geothermal heat to the ocean. And it can change the ocean temperature and favor the formation of the ocean warm block. And we can see that there are three ocean warm blocks caused by the submarine and mist volcanic eruption during 2012 to 2022. And the first, the North Pacific block between 2014 to 2016 was observed near the United States. And we can see that the ocean warm block is quite near the Arctic. And I have done research in my master's degree, and I found that this ocean warm block caused by the submarine and mist volcanic eruptions, like the Hiroshima in Japan, and can cause the thickening of the Arctic sea ice. And also the North Pacific block favored the formation of the El Nino in 2015 to 2016. And it has a great impact on the Arctic and also to the weather pattern of the globe. And on the around 2019 to 2020, we can also observe the South Pacific block in the which caused by the several volcanic eruptions, like the Tonga, the volcanic submarine eruption in Tonga, and the White Island mixed volcanic eruption in New Zealand. And this very interesting because we have used the Argo flow data to try to track the geothermal heat from the volcanic eruption affect the ocean temperature. And this South Pacific block can have an impact in the Antarctica, in Antarctica. And I will talk the example later on. And finally, we have the South Pacific block again in 2012-22, which caused by the 2021 to 2022, the Tonga eruption. And it is very interesting because it is very complicated because the Tonga eruption released the volcanic aerosol and water vapor to the atmosphere, and also released the geothermal heat to the ocean. And there are very complicated, a series of the complicated impacts in the to the atmosphere and the ocean, and affect the atmosphere from the lower level to upper level, and also affect the ocean circulation and finally causing some extreme rainfall events and extreme temperature events in the globe. And now I am still doing the study on the impacts of Hunga eruption. And I think most of you can also do the same research on the Hunga Tonga eruption, because we have many open source of data provided in the internet by the government. And for me, I always use the Argo flow data to track the ocean data and the geothermal heat from the volcanic eruption. And I also use the MODIS satellite data to track the volcanic aerosols from the eruption and how the eruptions affect the Earth system. And so I think everyone is a scientist. So I hope after this presentation, you can be one of our member to do the study on the volcanic eruption and extreme weather. So the North Pacific block during the 2015 to 2016, it favored and strengthened the El Nino event. And in the left figures, it is the sea surface height anomaly. And as the warm water will expand its mass, so it increased the sea surface height. So we can see that in 1997 and 2015, the seas both year is in the El Nino phase. But we can see that 2015 has a great sea surface height and strong El Nino effect compared to the 1997, because the North Pacific block caused by the submarine and mist eruption warmed the ocean a lot. So it strengthened the El Nino effect. And also, because the geothermal heat warmed the ocean and it provides the energy to the formation of the hurricane. And it is a very interesting observation, its record. And we can see there are 3 hurricanes occurred in the same time on August in 2015. And because it is explained by the North Pacific block caused by the eruptions. And in 2019 to 2020, the South Pacific block can cause abnormally high temperature in Antarctica. And in our study, we use the Argo Ocean data. We see that the data, the Argo Ocean temperature profile record on data boils in the vicinity of White Island. We can see that we find there are enormous temperature high between 75 meter to 500 meter under the water depth. And it is the best explained by the release of geothermal heat from the submarine eruption and the mist eruption, like the White Island eruption in 2018, 19. And this hot water will be transported by the ocean current. And because of the easterly drift of the warm seawater from the South Pacific block caused by the Earth rotation, the sea surface data at Eagle Island was impacted the most, and the hot water accumulated nearby the Eagle Island. And in January in 2020, the sea surface temperature near the Eagle Island was about 4.7 degrees Celsius. And at the depth below 250 meters, the seawater temperature difference between January 2020 and other years in the past are relatively small. It is consists with the heat dispersion from White Island region, where the heat source originate from the sea floor from greater depth through submarine volcanism. And the warm seawater being less dense would in time acclimate as a sea surface layer. So that's why we can record warm water, enormous warm water on the sea surface in Eagle Island, and we can find there are relatively small difference below the 200 meter at the depth of water depth compared to the other to the past year. And in this picture, we can see that the air temperature in Pacific Ocean and near the Antarctica, and a new record in hottest temperature of 18.3 degrees Celsius was established in February 6 in 2020 at the northern tip of the Antarctica Peninsula, and a hot spell lasting 9 days was responsible for a serious melting of glacier, ice sheet, and sea ice. And so the South Pacific blob in 2022 caused by the Hunga Tonga eruption, I will talk in later slide. And in January, it changed the weather, the rainfall pattern in Australia and New Zealand. And the Hunga Tonga eruption in 2021 and 2022, it is a very rare mixed volcanic eruption history. And I have mentioned several times before, and it released a large amount of sulfur dioxide, water vapor, and geothermal heat to the atmosphere and ocean. It changed the Earth system and caused a serious extreme weather. And during the eruption, we can see that the central part of Tonga Island was destroyed by the eruption based on the satellite image. And we can see that a large amount of the volcanic ash released by the Tonga eruption to the atmosphere. And about 400,000 of sulfur dioxide and 115 teragram of water vapor released by the Tonga eruption. And interestingly, this a large amount of water vapor released by the Tonga eruption increased globally by more than 5%, and it was and it is have a great impact to the whole Earth system. And the impact of the water vapor, we need further research on it because it is very rare case about the large amount of water vapor to the atmosphere. And I think the impact of the water vapor from the Hunga Tonga eruption can last for several years. So I think we need more research on it and try to re-estimate the role of volcanic eruption. And based on the Ghost Himawari 8 satellite image, at the height of volcanic ash from Hunga Tonga eruption is over 15.8 kilometers. And the volcanic ash and this kind large amounts of volcanic ash enter the stratosphere and can have a great impact to the Earth system from short-term, middle-term, and long-term effects. And here, I just read different open source of satellite data provided by the different government, like the NASA. And I find that the volcanic ash from 2021 to 2022 Tonga eruption circled the globe within about 20 days. And even a month after the eruption, around mid-February of 2022, some data detect a partial distribution of volcanic ash to the lower latitudes of the northern hemisphere. And more ash plume spread from southern hemisphere to the northern hemisphere under the effect of the summer monsoon. And we can see that the impact of the volcanic ash from the Hunga Tonga eruption not only present in the southern hemisphere, but also spread around the globe. And it can affect the weather pattern in the whole Earth, and not just focus on the regional weather pattern nearby the Tonga region. And the impact of the Hunga Tonga eruption can explained in 3 aspects. First, the short-term impacts of the Tonga eruptions. The volcanic ash plume and geothermal heat from the eruption entered to the atmosphere and the oceanic circulation. And the volcanic aerosols can reflect, the volcanic eruption and the water vapor from the eruption can reflect the incoming solar radiation and decrease the temperature in lower and upper atmosphere. And we in the upper atmosphere, the data find that record the temperature in mid-stratosphere dropped about 3 to 4 degrees Kelvin in March and April in 2022. This is an extent of the title. And as the temperature changing caused by the volcanic ash plume and the water vapor from the Tonga eruption, it changed the jet stream pattern. And the aerosols weaken the temperature gradient between the tropics and the poles. It favors the development of the jet stream wintering. And after that, an upper trough caused by the jet stream promote the air convection and bringing a large amount of water vapor into the air and facilitating the development of atmospheric vapor. And finally, cause a heavier rainfall in eastern Australia and New Zealand. And besides the volcanic ash and the water vapor from the Hunga Tonga eruption, the Hunga Tonga eruption also released a large amount of geothermal heat to the ocean and caused the ocean warm block in South Pacific Ocean. And it increased the latent heat flux from the ocean to the atmosphere, and it favored the cloud formation and changed the rainfall pattern. The ocean warm block also changed the pressure distribution over the ocean. And finally, combined with the volcanic aerosol and water vapor to the atmosphere released by the Hunga Tonga eruption, it changed the angle to the La Nina phase. And finally, it caused different high rainfall events in Australia, New Zealand, and South Asia and the Indian Ocean. And here we can see that jet stream wintering was observed after the Hunga Tonga eruption. And in the black circle, we can see that there's an upper trout caused by the jet stream wintering was observed over the eastern Australia and New Zealand on the 1st and 23rd of February in 2022. In the lower atmosphere, the region ahead of the upper trout favored air convergence, while in the upper atmosphere, the opposite air divergence was favored. And it increased the water vapor, in the atmosphere and generate unstable condition and produce heavy rainfall to the eastern Australia and New Zealand. And additionally, the upper trough caused by the jet stream wintering also facilitate the development of atmospheric river. And we can see that there is an atmospheric river caused by the jet stream wintering affect the New Zealand. So that's why a month of the Hunga Tonga eruption, New Zealand record an extreme rainfall in February in 2022. And in this slide, we can see that the geothermal heat from Hunga Tonga eruption affect the sea surface temperature. And around 42 square kilometer of discolored water was observed near Hunga Tonga Island during and after the summer the eruption. This large pool of abnormally warm water transported by ocean current and finally formed the South Pacific Ocean. And we can see that from the first time of the Hunga Tonga eruption, the ocean temperature over the South Pacific Ocean increased. And after around 40 days of the Hunga Tonga eruption, there was a South Pacific block connected to the ocean to the Tonga can be observed to be at the hottest east of New Zealand with an arm reaching the coast of South America. And after the second time of the eruption of Hunga Tonga volcanoes, it provides an additional large amounts of geothermal heat to the South Pacific block, and it finally caused the South Pacific warm block extended to Argentina, to the South America, and it covered the almost the whole South Pacific Ocean, and it favored the La Nina event, and also a series of impacts on the ocean circulation and atmospheric circulation. And in the left image, we can see that the sea surface temperature during the 13th of January to the 5th of February in 2020 to an increase in size of the hot pool of ocean temperature exceed 2 Celsius degree. Normal reach a maximum total area of around 170 square kilometers. And this a large warm pool of seawater caused by the Hunga Tonga eruption increased the latent heat flux near the eastern Australia. And in the right side of image, we can see that the high latent heat flux anomaly was observed over the eastern Australia and New Zealand in February 2022, and which it is caused by the geothermal heat from Hunga Tonga eruption. And this hot sea, it means the hot seawater increase the amount of water vapor transport to the atmosphere from the ocean, and it facilitates the cloud formation and provide additional energy for the formation of a tropical cyclone. And combined with the volcanic aerosol and the water vapor from the Hunga Tonga eruption, the Hunga Tonga eruption caused the extreme rainfall event in the eastern Australia and New Zealand. And during the month of February 2022, there are many stations in Australia record have a breaking rainfall record. And the New South Wales in Australia had anomalously wet February with many new rainfall records. And for the state as a whole, February of 2022 rainfall in Eastern Australia was 29% higher than the average between 1961 to 1990. And severe flooding occurred in Queen's Island and New South Wales, with over 58,000 homes flooded at the end of the February of 2022. And not just Australia had extreme rainfall event. In New Zealand, we can also have different have a great extreme rainfall record in New Zealand. And differently, New Zealand also affected by the tropical cyclone caused by the Hunga Tonga eruption, as the Hunga Tonga eruption provides a large amount of geothermal heat to the ocean, and it provides the energy to the formation of the tropical cyclone. And that's why the New Zealand not only affected by the hot water caused by the Hunga Tonga eruption, but also affected by the tropical cycle, which also explained by the Hunga Tonga eruption. And we can see that in New Zealand, Masterton Airport record its wettest day with 124 millimeter day on 12th February. And also the Kelvin in Wellington had its second wettest day since 1933 with 152.5 millimeter of rain on 13th of February 2022. And we can see that the Hunga Tonga eruption caused the extreme rainfall events in the eastern Australia and New Zealand through the impact of through the release of volcanic eruption and water vapor to the atmosphere, but also release the release of geothermal heat to the ocean, and finally change affect the whole Earth system. And not just the Australia and New Zealand affected by the Hunga eruption. And there are several places record high rainfall anomalies which caused by can be explained by the Hunga Tonga eruption. And we can, in this image, we can see that the South Asia, the Indian Ocean, also record high rainfall anomalies, which caused by the Hunga Tonga eruption. And in the middle term, impacts of Hunga Tonga eruption. As I mentioned before, the South Pacific Ocean block caused by the Hunga Tonga eruption increased the ocean temperature, and which favored the formation of La Nina condition. And also, the La Nina condition caused by the Hunga Tonga eruption can change the pressure pattern over the Pacific Ocean, and it can strengthen the tropical wind pattern. So finally, it caused some places in South Asia receive high rainfall amount. And besides the geothermal heat from the Hunga Tonga eruption favored the La Nina condition, the volcanic aerosols released by the Hunga Tonga eruption can favor the development of the stratospheric cooling in the southern hemisphere. And we can use the satellite data. We can observe there are the stratospheric cooling in the southern hemisphere during June to August 2022. And because due to the stratospheric cooling in the southern hemisphere, it changed the jet stream pattern. And we can observe the strong jet stream wintering since July of 2022. And also we can observe a strong Pacific trade wind between July and September 2022, and finally caused a high rainfall rate in many Asian countries. And I'm not the professional on the atmospheric scientist, but the impact of the stratospheric cooling caused by the Hunga Tonga eruption, it changed the QBO phase, the strong easterly phase. And in the easterly phase of QBO, it favored the weak polar vortex occurred. And finally, it allowed the cold air from the polar to the lower latitude, and finally caused some extreme cold event in East Asia, the United States, and Canada, and Europe since the October in 2022. And here is the July of 2022. The air temperature in 10 millibar and 200, and the vector wind anomaly in 215 millibar. Compare with under the 1991 to 2020 climatology. And we can see that the water vapor and the volcanic aerosol from the Hunga Tonga eruption reflect the incoming solar radiation and leading the stratospheric cooling of the southern hemisphere during the August 2022 and affect the atmospheric circulation. And finally, this stratospheric cooling caused the jet stream wintering and affect the weather pattern over the Pacific Ocean. And we can see that a strong tropical trade wind caused by the jet stream wintering and the geothermal heat causing the formation of South Pacific Ocean. And the tropical trade wind is unusually high with high wind speed and transport the water vapor and brought the rainfall to some Asian countries. And particularly the Indonesia received an extremely high rainfall amount. And when the stratospheric cooling occurred in the southern hemisphere caused by the Hunga Tonga eruption, the equatorial upwelling intensifies with favors the easterly phase of QBO, and it weakened the polar vortex and finally caused the jet stream wintering in the northern hemisphere. And it will change the temperature of the upper atmosphere and finally cause the strong atmospheric warming in the northern hemisphere. And it weakened the polar vortex and allowed cold air from poles to the lower latitude area. And in these figures, we can see that there is a weak polar vortex was observed in January of 2023. And the polar vortex split into two cells. And it means the cold air from the polar can move to the lower latitude easily. And finally, it caused extreme cold event over the United States, Canada, Japan, and Europe. And for example, we can see that there are jet stream wintering over the polar jet stream. And it allows the cold air move to the Canada and United States. And that's why we can see there are many news about the extreme cold events in the United States and in the Canada. And not just the cold event occurred in United States and Japan and Europe, but also there are historic winter warm events in Europe during the winter of 2022 and 2023. And we can see that in short term and middle term, the Hunga Tonga eruption can affect the rainfall pattern and the temperature pattern over the globe. But for the long term, I think we need further research on it because there are very few examples that the volcanic eruption released a large amount of water vapor to the atmosphere. And we don't know the impact of those extra water vapor, how this kind of water vapor affect the Earth system. But in the Hunga Tonga eruption, it released a large amount of water vapor equal to 10% of total stratospheric water vapor to the atmosphere. And it increased 13% of global stratospheric water mass compared to the climatological level. And we can see that from the start of the Hunga Tonga eruption, the water vapor from the eruption spread to the over the globe and even last for several years until the present. And it can have a potential impact to our weather and climate pattern. And this kind of large amount of water vapor and volcanic materials from the Hunga Tonga eruption can remain in the atmosphere for many years and can affect the temperature change of the stratospheric and troposphere spheric circulation. And it can cause jet stream wintering or weaken the polar vortex or other atmospheric impact. And finally, we can see some examples of extreme weather events over the globe, like some extreme cold events United States and some heavy snow in Alaska, in Japan. And it can be explained by the Hunga Tonga eruption. And after a year of Hunga Tonga eruption, the effect from the eruption is still present. And it favored, it changed the atmospheric circulation and favored the strengthened level of the tropical cyclone. And finally, in Hong Kong, it recorded a historic rainfall and flooding in September 2023. And it broke the rainfall record of in 1952. And according to the Hong Kong Observatory, more than 200 cases of landslide and 18 cases of flooding occurred in Hong Kong due to the impact of super cyclone Solar on the 1st and 2nd September, and Typhoon Hai Kui and Black Rainstorm on the 7th and the 8th of September. And it is the sixth highest hourly rainfall on record respectively. And it is a heaviest rainfall in Hong Kong record in 140 years. And we can see that such large amounts of water vapor from the Hunga Tonga eruption can have many impacts on the Earth system and have potential to lead change of effect, leading different kind of regional extreme weather patterns after 2022 and last for several years. And we need further investigation, research on it. And also, the water vapor from the Tonga eruption can lead to the ozone depletion. And study from the Harvard University have found that the large amount of water vapor and sulfur dioxide from Tonga eruption can change the stratospheric chemistry and dynamics, and finally cause the ozone depletion. And in this data from NASA, we can see that there is low ozone concentration over the tropics, and the reduction of stratospheric ozone can means it can exchange the polar wind and the harder cell displacement of precipitation belts, and it can affect the typical weather patterns over the Australia, South American, the United States, and also can affect can cause some warm and dry springs in Europe and Russia. The impact of ozone depletion on weather pattern, we also need further research on it. But I believe that the Tonga eruption impact have a great impact, can be last for several years, even today. And that's why I always mention that when we see the news of extreme weather events, first, we should not only consider the human activity causing the climate change, but also we also consider the impact, the role of volcanic eruption. I think some of the extreme weather events can be explained by the volcanic eruption, not just the human activities cause the climate change. And that's why today I want this presentation. I want to inspire all of you through this presentation and increase and change your mind on the impact of volcanic eruption. And in this presentation, we can see that the volcanic eruption can release the volcanic ash, water vapor, sulfur dioxide, and geothermal heat to the atmosphere and to the ocean. And this kind of the material released by the volcanic eruption can be transported by wind and ocean currents, and finally affect the Earth system and lead to a series of extreme events. And based on the location, the strength of eruption, and the seasonal timing, the volcanic eruption has different potential to influence the atmosphere and the oceanic circulation differently. The impact of the volcanic eruption is different. Every volcanic eruption has its different impact on the Earth system. And in this presentation, the extreme rainfall event in Hong Kong in 1982 and 2008, and the extreme rainfall in Australia and New Zealand in February of 2022 match with the e-loading time of 23 to 35 days for sulfur dioxide conversions to sulfate. And this is a very useful finding because we can, based on this principle, in the future research, we can use this principle to assess the impact of the volcanic eruption. In the simple way, we can assess the rainfall change of rainfall pattern after 23 to 35 days of the volcanic eruption and see is there any increase or decrease abnormally rainfall amount record in different places to track the impact of the volcanic eruption. And also, the volcanic eruption released the geothermal heat to the ocean, and it caused the formation of the ocean wall block. And this is very interesting because it is very this aspect is always underestimated by all of us, and we still do not know the impact of geothermal heat from the volcanic eruption on the Earth system. And the geothermal heat can cause the formation of ocean warm block and link and it can cause the change of the atmosphere and also change the oceanic circulation and causing a serious impact on the Earth system, like causing the angle, changing the angle to La Nina phase or strong El Nino phase, and also can provide energy to the cyclone formation and increase the cloud formation and affect the rainfall distribution over the globe. And I think we should, in the future, we should do some research on this aspect of volcanic eruption impact. And also in this presentation, we can see that the Hunga-Tonga mass eruption in 2021 to 2022, it is a very rare event in history. And because it released a large amount of volcanic materials, including water vapor to the atmosphere, and its impact can be last for several years, potentially affecting the regional as well as global weather, from extreme rainfall to ocean variation and some extreme cold event over the globe. And finally, I want to talk about, I hope through this kind of findings, it can improve our understanding on the impact of volcanic eruption on extreme weather events, and it will not only assist volcanic risk assessment, but also improve the regional and global climate prediction. And I know most of our weather prediction model is only considered the impact of climate change, but it neglects the impact of volcanic eruption. And I hope these findings can improve our minds and improve our weather prediction model and consider the impact of volcanic eruption into the prediction model. And finally, we can have a more accurate prediction result. And in the last slide, I show this graph again because I think it is important to show different kinds of the volcanic eruption, how the eruption can affect the whole Earth system through different ways, from geothermal heat, but also volcanic materials to the atmosphere. And so I hope all of you enjoy my presentation. Thank you.
Okay, fantastic presentation. I really enjoyed that. Do you have time for a question? Yeah, I mean, you just mentioned that at the end that this can help us predict the weather in the future, but do you think we know enough about the effects of these volcanoes now that if a Hunga Tonga-like one occurred again, or some huge one occurred again, we could take all the data that we get in the first few days about exactly what happened and then make predictions 30 days out in the future on the other side of the globe what's going to happen? Or do we not understand it well enough to do that yet?
I think Hunga Tonga eruption provide a good data for the prediction model, and it is quite difficult to predict the occurrence of the occurrence of the volcanic eruption. We only based on the earthquake data and some kind of the temperature, ocean temperature change data to predict the occurrence of volcanic eruption. But based on the Hunga Tonga eruption, it can provide a background of the potential impact of volcanic eruption. And if in the future there is a volcanic eruption like the Hunga Tonga eruption, we can based on our experience on the Hunga Tonga eruption, and we can check the volcanic materials from the eruption and try to assess the impact of those volcanic materials to the earth. And so I think Hunga Tonga eruption is a quite good experience for us for predicting and the assessment of the volcanic eruption in the future.
So I am curious about the local forecasting when Hunga Tonga did happen, that those huge rainfalls hit Hong Kong. Was there some warning ahead of time, like the forecast 5 or 10 days out? Did they anticipate that huge rain, or was that kind of a surprise?
In Hong Kong, I remember that there are some forecast model which predict a very huge huge level strong tropical cyclone will occur, extreme rainfall in Hong Kong. But the forecast model do not predict the damage of those tropical cyclone, because the forecast model only predict the cyclone will go through Hong Kong, but they cannot predict there are another black rainstorm will occur in Hong Kong. So finally, Hong Kong received full tropical cyclone event and one serious black rainstorm during 1 to 2 weeks, and that's why finally we had different flooding and damage in Hong Kong, and also we had it caused a huge damage of economic cost and loss in Hong Kong. For example, there are a huge amount of fish death in the agriculture in Hong Kong, and basically, and in my observation, the website from the Hong Kong Observatory only explain this kind of the extreme rainfall event caused by the tropical cyclone. They only tell us this tropical cyclone event caused by the climate change and which related to the human activity. But they neglect the impact of the volcanic eruption. So I think not just the Hong Kong Observatory, but all of the government departments over the globe should consider the impact of the volcanic eruption in their future weather prediction model. And they still neglect the impact, the role of volcanic eruption in their prediction model. So that's why even they can predict the tropical cyclone formation over the ocean and go through their city, but as the volcanic eruption can provide additional energy and impact to the formation of the cyclone, and it can strengthen the tropical cyclone and finally cause an unexpected rainfall event than our expect.
All right. Any other points you want to make before we finish this one up?
I think because I'm a new researcher in the volcanic eruption on the extreme weather event. I know why I start my findings on this topic, because I always see the NGOs only tell the public the climate change caused by the human activity, but without any scientific data. For example, the Hunga Tonga eruption in 2021 and 2022, there are some extreme rainfall events in South Asia, in Australia, New Zealand, but I read many news on this extreme weather event, the flooding event in those areas. The news only tell us the climate change caused by the human activity. But I don't know why they neglect the impact of the Hunga Tonga eruption, because the eruption occurred before the extreme rainfall event 1 month before. This kind of rare event in history released a large amount of volcanic eruptions into the atmosphere and ocean. It must have a great impact to the Earth system. So I don't know why the public neglect the impact of the Hunga Tonga eruption, and only tell us the public this kind of extreme rainfall event, the flooding event, is caused by the climate change caused by the human activity. So I hope through this presentation, we should change our mind of the natural power, the natural factors on the climate change issue. Most of the extreme weather events, the Arctic sea ice plane, can be explained by the volcanic eruption. And I mentioned at the start of this podcast, a little bit of warm water, put a little bit of warm water into a bathtub. It can change the whole the whole temperature of the bathtub. So like the volcanic eruption not just affect the regional area nearby the eruption site, but also can affect the whole global weather pattern, and its impacts can be last for several years. So maybe my language level is not good, but I hope I can fully explain our findings of the impact of volcanic eruption on the weather event. And in this graph, when I make this graph, it is too many information I want to put into this graph because it is very complicated about of the impact of volcanic material. But I just simplify the graph, but still we can see the impact of the volcanic eruption is quite a lot. It's rather than our expectation. And I know there are some huge volcanic eruptions in Russia and Indonesia last year. And I'm still doing the research on its impact of those volcanic eruptions. And I found some kind of rainfall event in the can be explained by this volcanic eruption. And I hope in the future I can also explain my findings with my colleague, Professor Reddim, Dr. Engineer Roy from University College London. So I hope we can have another opportunity to show our findings to all of you. And thank you again, Tom, to give me an opportunity to hold this podcast. And I think my presentation is not good because my language is not very good. But thanks all. Thank you.
All right. Yeah. Thank you for the presentation. I'd love to have you on again. This is fascinating stuff. And I do think one reason why the scammers want to blame humans and not volcanoes is because they can tax humans and they can't tax volcanoes. But thanks again for your work, and we will talk to you next time. Alvin Wong.
Thank you. Thank you.